All right, everybody, let's do some examples. We are going to find the power of a product. We went over kind of how it comes about and why it works. So just to review that really quick, to find the power of a product, find the power of each factor and multiply each by the exponent on the outside of the grouping symbols, okay? So we're not multiplying the exponents on the inside by each other. We're multiplying each of those by that outside exponent. So let's take a look at a few examples and see what we got here. So my first example that we're going to do is this good old problem, 8b to the ninth, and we're going to square that. So I picked something that I could write out easily if we had to. Well, we know that if I were to expand this, it would be 8b to the ninth times 8b to the ninth, and that would be a lot easier. But let's use that rule, all right? So let's take this exponent, and we're going to multiply it by both the exponents here. Now, remember, if something doesn't have an exponent, and most of the time the numbers are not going to have exponents listed, the exponent is 1. Okay, so we're going to do this 8 first. So 8's our base, and we have 1 times, and then we have, now we'll just leave it that, 1 times 2. And then for our b, let's do b in green. We have b, and then my exponent is 9, and we're multiplying it by 2. And so we've broken it down, we've simplified it, and we're going to say that whole thing, if we simplify that, would give me 8. So 1 times 2 is 2. And then b, 9 times 2, is going to give me 18. So we have 8 squared, b to the 18th. Let's simplify this 8 squared really quick. Well, 8 times 8 is 64. So that's going to give me 64 times b to the 18th power. All right, let's try another one. All right, another example. And this is where you're really going to see how nice this rule is, because it starts saving you a lot of time. So this whole thing to the 4th power. Now, I could sit and go, well, 6x to the 5th, y to 11th times 6. I don't want to do that. That is lame and a lot of work, and I don't want to waste my time, to be completely honest with you. So I'm going to take this exponent here, and I'm going to apply it to each of the terms in here. Now, in this one, I have 3 different terms. I have 3 different factors that I'm applying it to. The 6, remember, my exponent would be 1. My x is to the 5th, and my y is to the 11th. So these are the different things I have going on. So I'm going to have 6 to the 1 times 4 power. I'm going to have x to the 5 times 4 power. Sorry, I kind of made that hard to see. And then you have y to the 11 times 4 power. Do you see the pattern here? Is that in all of these, we're multiplying each of them by 4. Okay, you're multiplying each of this. So this whole thing without the 4's is this original monomial, and then you multiply everything by 4. So that gives you, and we'll keep it green as long as I have it pulled up, 6 to the 4th times x to the, well, 5 times 4 is 20, and then y to the 44th power. And it gets pretty huge pretty quick. And then you just got to figure out what 6 to the 4th is. So you would say, well, 6 times 6 is 36, and then times another 6 times 6, that's 4 6's. So it's 36 times 36. And if I figure out what 36 squared is, you get a big number. And you get 6, 9, 2, 12. So you would get 1296, x to the 20th, y to the 44th. A lot of calculators will help you out with making that a lot easier. You can actually punch in exponents on a lot of calculators. All right, one more example, and then we'll be done. So let's go back to my white here, and we've got -5. I know you're going to love that. W squared z to the 8th raised to the 3rd power. So again, we're taking this exponent right here, and we're applying it to all the exponents here. Now remember, -5 doesn't have one, so we're going to assign it 1. All right, literally 1. So let's do that first. I do not want the highlighter. We're going to do -5. Now I'm going to put this in parentheses because it's going to kind of change how we evaluate it. And then I have w squared times 3, and I have negative 1. I should write it like this, 1 times 3. And then z, the 8 times 3. So you notice if I get rid of all these 3's again, right? If I were to ignore them, it would look a lot like the original monomial up here. You're just applying that 3. So it's kind of like the distributive property. And so now I'm going to have negative 5 to the 3rd power times w to the 6th power times z to the 24th power. And then we want to simplify that. So that's negative 5 times negative 5 times negative 5. Well, negative 5 times negative 5, you have a negative times a negative, which gives you a positive 25. And then a 25 times 5 is 125. And then you have a positive times a negative, which gives you a negative. So you would get negative 125 w to the 6th, z to the 24th power. And like Khan Academy always says, we are done.